All right, section 3.4 in our textbook describes angles of a triangle. So we've talked about the different types of triangles. Now we want to talk about some properties of triangles that are going to help us with problem solving. And we start out with theorem 311, and this says the sum of the interior angles of a triangle is 180 degrees. What that means is if I'm looking at a triangle, I know that angle 1 here plus angle 2 plus angle 3 have a sum of 180 degrees. Always. It doesn't matter if it's an obtuse triangle or a right triangle or an acute triangle. They always add up to 180 degrees. We just need to make some room for some problem solving here. Our first example is you might get a problem that says find x on this picture, and you don't want to be sarcastic and say, oh, here it is. Okay, we're looking for the value of x. So in this problem we say, oh, I have three angles of a triangle right here. I could say that 38 plus 3x plus 5, that's this angle, plus this angle, plus the last angle, 3x plus 5, all have a sum of 180 degrees. Now when we have a problem like this, we want to combine like terms. So we have 6x plus 48 equals 180. Subtract 48 from both sides and we get 6x equals 132. And I believe x is equal to 22. And that's what you would do for that problem. Many times in geometry we get things called corollaries. Now corollary is like a subtheorem or a theorem under a theorem, and it's something proved directly from a previous theorem. So corollary 1 under theorem 311 is just something tied into the three angles of a triangle at up to 180 degrees. And that says if two angles of one triangle are congruent to two angles of another, then the third angles are congruent. And what that means, if I have two triangles right here, now notice they're different sizes, but the angles, this is a 50, and that's 50. This is a 40, and that's a 40. Since those angles are congruent, then we can conclude that the last angles, x and y, are equal. Corollary 2, which is proved directly from theorem 311, saying that the three angles of a triangle make 180 degrees together, it says that each angle of an equiangular triangle is 60 degrees. The reason we know that is because we said that all the angles would be equal, and if we have x plus x plus x equals 180, then 3x equals 180. So x is 60. And most people don't have too much trouble figuring that out. An example of how we would use that is to say one of the angles of an equiangular triangle has measure 3x minus 15. We're supposed to find x. Again, since this is one of the angles of an equiangular triangle, it must be equal to 60 degrees. And we add 15 to both sides, and then divide by 3. And then we'd be finished. Corollary 3, another corollary under theorem 311. There's a lot of these because knowing the three angles of a triangle make 180 degrees really, really gives us a lot of information. It can tell us that in any triangle, there can be at most one right or obtuse angle. And I posed the question here, well, what if there were more than one? And we said before, if we had an obtuse angle and then another obtuse angle, we would never be able to make a triangle out of this because these two lines will not meet out here in space anywhere. So it won't make a triangle. If we went across, we'd be making a quadrilateral. So since we just had a theorem that said the three angles of a triangle make 180 degrees, two obtuse angles make it over 180 degrees. 2 right angles would do that already, so that the third angle would be 0, which is impossible. Our last corollary under theorem 311 is corollary 4, and it says the acute angles of the right triangle are complementary. The reason we know this is because if we have x plus y plus 90, the 3 angles of this triangle equal 180 degrees. When we subtract 90 from both sides, x plus y, we get x plus y equals 90, and that's the definition of complementary angles. So we know that the acute angles are going to add up to 90. It just saves us a step later on. Instead of having to say that add up to 180, you could just go directly to saying that these two guys add up to 90. But the nice thing is, if you ever forget, you could always just use the 3 angles of a triangle adding up to 180. An example, if it says find the value of x, instead of saying that these 3 add up to 180, I could just say that the 2 acute angles add up to 90 degrees. And that's going to give me 5x plus 30 equals 90. And I'll just finish that up here. Finish off your algebra there, and you're finished. Our last theorem in this section is theorem 312, and this one's special because a lot of people forget this one, and it's actually a big time saver. And what this says is the measure of an exterior angle of a triangle. An exterior angle is just when you extend one of the sides out like I just did here. This side was extended to create an angle on the outside. The measure of that exterior angle is equal to the sum of the measures of the 2 remote interior angles. Now you might say, what in the world are remote interior angles? Well, the remotes are the ones that are not adjacent to that exterior. So here's an angle adjacent to that exterior angle. So that's not a remote interior. The remote interiors are the other 2 angles. The way I like to think about it is if something's far away from me, far away from this guy here, you would need a remote to turn it on if it were a TV or something like that, or some kind of device that needs a remote. And the one right in front of you, you don't need a remote, it's right in front of you. I don't know if that helps, but so what we know is that 12x minus 23 is equal to the 2 remote interior angles added together, 6x plus 6 plus 4x plus 3. Those are those angles right there. So the exterior angle equals the sum of the remote interiors, and we can add 6x and 4x to get 10x, and add 6 and 3 and get 9. And from here, this is, again, more algebra. We subtract 10x from both sides and get 2x minus 23 equals 9. Add 23 to both sides, and we get 2x equals 32. And you end up with x equals 16 when you divide by 2 on both sides. And you're finished. And that concludes all of our notes for section 3.4.